Hi everybody, today we are going to start talking about the three-dimensional coordinate system. Okay, so a three-dimensional coordinate plane now has an additional axis. Now we are going to add in that z-axis. So for our purposes and how you'll see it in our textbook, the x-axis is going to be kind of jumping out at you. Like imagine this is actually coming out of your page and we're going to draw it in this direction. Our y-axis is now going to be this horizontal axis and z is going to be this vertical axis. So you can see that with our xyz coordinate plane, there's actually three different planes that intersect different combinations of your axes. So let's start by looking at this plane in blue. If you look at this blue plane, you can see that it actually intersects our y and our z axes. So we call this the yz plane. Now if you look down here, it says x is the directed distance from the yz plane. So if you start at any point on x and then either you're moving forward or backwards off your page or into or behind your page, that's the movement that x represents. Now let's look at the green plane. So if you look at what that is intersecting, that's intersecting with our our z and the x axes. So we call this the xz plane. And notice that y is the directed distance from the xz plane. So imagine you're anywhere on that green plane and you're moving out to the left or out to the right. That's the direction that y moves. And now let's look at that last plane, that plane that's kind of reddish. We see that it intersects with our x and y axes, so we call that the xy plane. And then, of course, z is the directed distance from that plane, so anywhere on your red going up or down. All right, so let's try to plot some three-dimensional points. So here, we are just going to do our best to make it as three-dimensional looking as possible. So just a little tip how I usually approach it. I usually start with just my x and y values. So I see that my x value is positive 2. So here's my x-axis, and anything coming out of your page, coming forward, is positive. So positive 2 is going to be here. I'm just giving myself a little guideline. And for y, of course, negative is going to be the left, so I have negative 3 right here. So we want to figure out kind of out in 3 dimensions where the intersection would be. So we're always going to try to create lines that are parallel to our axes. So I'm going to draw a line that's parallel to x and parallel to y. So we draw something that looks kind of like this. So that's going to show where our point is before we incorporate our y value. Since our y value is positive, we're going to go up 3. So you're just going to kind of estimate what you think 3 units up would look like. And this is where our point is. So you can see when we are given these 3 guidelines, you can tell that our point is coming off our page and it's in that front left quadrant on the top. So you do need to find some way to show which area your point is in. And like I said, I always start with the x and the y, and I make a parallelogram shape for the base, and then I either move up or down for my z value. I do want to point out that this z value of 3 is not going to match up with this because this is 3 units from your origin. Here we're going 3 units up from some point in space, so you just kind of estimate what 3 units would look like, and this is the point. So let's try this next one. We'll start with just the x and the y. So x is negative 2, so that's going back behind your page, and y is positive 6, so that's moving to the right. And once again, let's make a little parallelogram to show out in space where that intersection would be. And then our z value is 2. So from this point on our xy plane, I'm going to move up 2 units. So I just estimate what 2 units would look like, and that would be right here. So with those 3 lines, you can tell clearly where the point would fall. Now let's try this last one. So same thing, let's start with x and y. X is positive 2. Y is positive 2. Let's create our little parallelogram there. And here our z value is negative 3. So we're actually going to go down by approximately what looks to be 3 units for our graph. So there you go. Just do your best to provide these three-dimensional guidelines so you can clearly tell where your coordinate is being plotted. Okay, so now we're going to talk about a few formulas that might look extremely familiar to you guys. We're going to talk about the distance formula, and then we're also going to talk about the midpoint formula. So you'll notice that actually if we took out this last part of this formula, we do just have the distance between 2 points on a two-dimensional plane. So for a 3D plane, all we have to do is add in this additional term, the difference between our z values squared. So you'll see that with three-dimensional coordinate planes, many of the formulas or the equations are going to be very intuitive because they're very similar to 2D. Okay, let's see if we can find the distance between the coordinate 1, 0, 2 and the coordinate 2, 4, negative 3. So our distance is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. So this is just going to be the square root of 42. It's as easy as that. Okay, go ahead and pause the video and give this one a try. Okay, so here, same idea, y2 minus y1 squared, or x2 minus x1 squared, y2 minus y1 squared, z2 minus z1 squared. You should get the square root of 35. Okay, so now let's talk about the midpoint formula. Once again, this should look really familiar. Actually, if we take out this last term, this is just the midpoint between 2 points on a two-dimensional coordinate plane. So once again, we just have to add in that extra term to find that z value. Okay, let's see if we can find the midpoint of the line segment joining 5, negative 2, 3, and 0, 4, 4. So using our formula, we'll do x1 plus x2 over 2, y1 plus y2 over 2, and z1 plus z2 over 2. And what we're left with is 5 halves, positive 1, and 7 halves. So that is the midpoint of those two coordinates. Okay, go ahead and pause the video and give this one a try. Okay, so here, same exact formula. You should end up with 5, negative 3, 1. All right, and now we're going to talk about the standard equation of a sphere. So once again, you'll notice that if we take out this last part, we actually have the standard equation of a circle. So for a sphere, we do have to account for that z value, which means we also need a new variable to help us represent our center. So before, for the center of a circle, it was always hk. So for that third dimension, we're going to use the variable j. So we'll call our center hkj. Our radius is still r, and notice that we still have r squared here. So it's just x minus h squared plus y minus k squared plus z minus j squared equals r squared. So if we want to find the radius, just make sure to take the square root of that value. So from here, let's talk about how do we graph, or how do we sketch a picture of a sphere. So let's say here's our sphere and this is our center at hkj. The way that you can show that it's three-dimensional, you kind of draw a line on the front and then a dotted line in the back like this. So that shows that it's not a circle, but actually a three-dimensional sphere. And then, of course, the distance from the center to any point on your sphere is just your radius. Okay, so let's try finding the standard equation with a sphere that has a center of 2, 4, 3 and a radius of 3. And then we're going to talk about whether or not this sphere intersects with the xy plane. So the equation is pretty straightforward. X minus h squared plus y minus k squared plus z minus j squared equals r squared. So it should equal 9. Now, if we sketch a really quick picture of this sphere, here's y, here's z, and here's our x-axis. So we know that our center is somewhere here, here, and then up 3. So this is the center of our circle. Now, notice they want us to find if it intersects with this xy plane. Well, if you think about it, our center of our sphere falls 3 units above the xy plane. It's literally 3 units up from this intersection. And our radius is 3. So since our radius is the same distance as our z value, we know that our sphere will in fact hit that xy plane. So you can actually sketch it out, and then you'll see it actually has a point of tangency on that xy plane. So here's what our sphere would look like, something like this. And once again, since that radius is 3 and our center is exactly 3 units up from our xy plane, will it intersect the xy plane? The answer to that is yes. And that occurs right here. Okay, go ahead and pause the video and see if you can find the center, or the standard equation of the sphere with a center of 1, 3, 2 and a radius of 4. Okay, so here, pretty straightforward. X minus 1 squared plus y minus 3 squared plus z minus 2 squared equals 16. And if you look at the distance of our radius and where the center is, you can see that since the radius is longer than any of these directed distances, this sphere is actually going to intersect with all 3 of our coordinate planes. Okay, so now we're given a different form of our equation for a sphere, and they would like us to find the center and the radius. So of course, we did this many times with our conic sections. We do need to put our equation into standard form, which means we're going to be completing the square not once, not twice, but 3 different times. So let's group our x values together, and we are going to complete the square there. We'll group our y values together, plus 4y. We'll leave a space to complete the square. Group our z values together, and once again leave a place to complete the square, and I'm going to move that 8 to the other side, so it becomes -8. Here the number that completes the square is 1, so I'm going to add 1 to both sides. Here it's 4, so I'm going to add 4, and here it's 9. Remember, it's that b over 2. And now we are ready to factor on the left. So we have x minus 1 squared plus y plus 2 squared plus z minus 3 squared, and it should equal 6. So we can see that our center is at +1, -2, +3, and our radius is the square root of 6. So there you have it. Okay, go ahead and pause the video and see if you can find the center and radius of this sphere. Okay, so here, same idea, group your x, y, and z terms, complete your squares, and make sure you are adding the same value to both sides. You should end up with this as your standard form equation, giving you a center of -3, +2, -4, and a radius of 6. Okay, the last thing we're going to talk about is what's called sketching a trace of a surface. So a lot of times when we're working with 3-dimensional shapes, it's really useful to think of the intersection with one of our planes and then to describe the 2-dimensional shape that occurs from that intersection. So imagine like you have a sphere that intersects with one of your planes. If you chopped a sphere or you slid a plane right through it, the shape that would make would actually be a 2-dimensional circle. So we can find that trace by either substituting 0 for y, x, or z, depending on which plane you're trying to find the trace for. And once again, we're essentially finding a 2-dimensional equation for that intersection with a 3D shape and a plane. So let's see if we can sketch the trace of this sphere, the xy trace. So they want to know what is the equation of the circle that's created when my sphere hits the xy plane. So let's see if we can first sketch out a quick graph of this sphere. We know that the center is going to be at 3, 2, -4, and our radius is going to be 5. Make sure you always label your axes. So this is y, this is z, and this is going to be x. So we know that it's going to be x is 3, y is 2, and then we're going to go about down 4. So our center is somewhere down here. Now, since our radius is bigger than all of these directed distances, it is going to intersect with all of our different values, or sorry, all of our different planes, so we can kind of draw it in like this. Okay, but once again, they don't want to know the this sphere. They actually want to know the xy trace of this sphere. So imagine we're kind of chopping our sphere with the xy plane. We are going to have some new circle that's kind of like this. So we're going to see if we can find the equation of this circle. So it's really easy to do. Since we're working on the xy plane, all of the values on this plane have a z that is equal to 0. So we're essentially going to set z equal to 0 and then solve the equation. So here we have x minus 3, or not solve it, we're going to put it into standard form. Plus 0 plus 4 squared equals 25. So you can see that this is the equation of a two-dimensional circle because we just have x squared and y squared. However, it's not in standard form. So we do need to subtract 16 from both sides, and we are left with x minus 3 squared plus y minus 2 squared equals 9. So this is the equation of our xy trace. This is the equation of that circle that's created that I drew in green. So notice that if you compare our original equation to our new equation, the center is directly above our original center of our sphere, but notice that our radius is smaller. That's because we're moving up the circle, and as we move up the sphere, sorry about that, our radius is going to be slowly decreasing. So here our radius is 9 compared to the original radius of 5. All right, for this last one, go ahead and pause the video. See if you can find the xz trace of this sphere. Okay, so for this one, since we're finding the xz trace, we're going to set y equal to 0. So here's our sphere, and we're essentially going to try to find the equation of the circle that occurs on the xz plane. So we set y equal to 0, we make sure to put our equation into standard form, and we have a circle with a center of 1/8 and a radius of square root of 91. Okay, that is all for today's lesson. Thank you for watching.